A further requirement from the business is to produce an output file containing countries where our priority customers reside. This should be a list of the unique countries, sorted alphabetically. In this demo, we'll learn how to use a sorted set to meet this requirement, and I'll demonstrate how cultural rules can play an important role in sorting. We'll begin in the Customer Data Unique Countries Writer class and start to provide the initial implementation for its write async core method. Besides LINQ, a viable option for sorting unique string data is to use a sorted set. We'll define a countries variable and assign a new sorted set of string to it. We can supply some initial data for the set in its constructor, selecting the country property from each piece of data. We'll add a breakpoint at the end of this method so we can inspect the countries during debugging. To execute our writer, we need to modify the process customer data samples async method. If we have any priority customers extracted from the data source, we will create an instance of our writer. The constructor accepts the processing options as well as a culture. We've loaded Danish sample data, so we will pass in a Danish Denmark culture info. We then invoke the write async method, providing a file name for the output, the source data, which is our list of priority customers, and because this method is asynchronous, we pass along the cancellation token. We can now build and debug the application. After supplying our user details, the breakpoint inside the Customer Data Unique Countries writer is hit. We can see its assigned value if I hover over the countries variable. At first glance, it appears that we've successfully produced a set of 7 unique countries sorted alphabetically. But take a closer look. That's not entirely correct. The first entry in this list begins with a character that may be unfamiliar. Danish has 3 extra letters when compared to the standard English alphabet. We see 2 of those extra letters in our sample data. These additional characters come after the standard 26 English characters, which means our sorting is inaccurate based on Danish rules. When not specified, sets use the default comparer for the generic type that's being sorted. The default comparer expects the type to implement iComparable of t, which string does. In the implementation of this interface, strings use the current culture for sorting. For our application, this will be the current application thread culture. We explicitly set that to be ENGB when we started our application, and so sorting has used UK English sort rules. In addition to the inaccurate cultural sorting, Australia also appears twice in the set. By default, the sorted set is case insensitive, and these values are considered distinct. This is not the desired behavior for our application. To ensure we consider culture and casing when sorting the strings, we need a comparer which understands the Danish rules. We'll define a private field to hold a string comparer instance. Inside the constructor, we can assign a value for this comparer. We'll call the stringcomparer.createFactory method. As the first argument, we must supply the culture info for the expected culture. We can use the culture info parameter from the constructor to make this comparer culture aware. A second parameter can be applied to decide whether to ignore case during sorting. We'll set this to true so that our comparison becomes case insensitive, the desired behavior to avoid duplicates which only differ by case. With our comparer initialized, we can pass it in as an argument to the sorted set constructor. The set will use this comparer when determining the correct order for the entries it holds. If I save this change, rebuild and run the application, we can observe the effect. This time, the list appears in the correct order according to Danish sorting rules. Countries which begin with the additional characters appear at the end of the set. It's imperative to consider culture when sorting strings. Additionally, we've removed the duplication of Australia because our set is now case insensitive. I'll stop debugging, remove this breakpoint, and close all files in the editor. The various types and methods in .NET may use different defaults for equality and comparison, and it's not always clear which comparer will be used in every case. As a rule, I recommend explicitly providing a string comparer to functions that accept one, even if you supply a value that aligns with the default behavior. In doing so, we avoid the risk of confusion and any future surprises. We've completed our look at string comparisons and sorting. Join me in the next module, where we will continue the development of the data processor and focus on applying several techniques for searching strings.